This video is going to talk about systems of equations. And when we talk about a system, what we're doing is we're talking about solving multiple equations all at once. And there are a couple methods algebraically that we can use to do that. The two we're going to talk about are what we call substitution and elimination. And when we solve it, what we want to do is we want to find a point, in this case, a particular point that satisfies both equations. We want to find a point that satisfies both equations. So you can write that as some x, y when we talk about two variables, or you can write it as a x, y, z when we talk about three. And then once we get past three dimensions, we're not really there yet, so we just need to stop. But in a 2D plane, that's graphing two lines and seeing where they intersect at. So we're going to start off by talking about this method that we call substitution first. And in substitution, we're going to recall a variable something new. But in order for this to work, we need to have a variable already isolated. So when we talk about a system just sets up as two linear equations like this, and you want to solve them at the same time. So to use substitution, one of your equations has to be written as a variable equal to something, isolated like this. This variable is isolated. And so what this is telling me is that when I look at this, I have x minus 4y is equal to 16. Is equal to 16. And now I'm telling you, though, that this y value, instead of calling it that right there, I can recall this as I can call that new y, this y right here, what I have it isolated as, which is 1 minus x. So I can actually say this is x minus 4 times 1 minus x, because that's what y stands for in that other equation. That's the whole substitution part. You're substituting there. And when I do that now I can solve this equation, distribute the 4 out here. So I'm left with x minus 4 plus 4x. That equals 16. Combine like terms over here. So that's 5x minus 4 is equal to 16. So here we're going to isolate this x variable again. Isolate the x, we're going to add 4 to both sides. So we add 4 to both sides. And when we do that, we get 5x is equal to 16 plus 4 is just 20. So solving for x, we need to divide both sides by 5. And I get x equals 4. So the first step is to isolate that variable and then plug it into the equation to get the value of x. Now that I know that the value of x, the next step says to solve for the missing variable. Once you have this value, go back to your isolated variable equation and solve for the other one. So now that we know that x is equal to 4, come back to the isolated value. I can plug in for that x there, and I can do this now. Y is equal to 1 minus that value I got for x, which is 4. So y is just equal to negative 3. And I can express this as a point, an xy coordinate. And when I do that, I get the value of 4, negative 3. What this means is that I can plug in 4, negative 3 to both equations, and it makes them true. Let's go ahead and evaluate that. So the first one will say 4 minus 4 times a negative 3. That should equal 16. And if I do this, negative 4 times negative 3 is a positive 12. So that's 4 plus 12. That equals 16. That is correct. If I do it to the bottom equation, I should get negative 3, because that's what y is equal to 1 minus 4. 1 minus 4. And if I do this, 1 minus 4 is negative 3. That makes that true as well. So that means that this point right here is the actual solution.